Okay, look at letter B. What is the velocity if the canoe heads 5 kilometers per hour east relative to the current? Okay, so now this is when we're gonna use the right triangle like I showed you. So we have the current of the river goes down 2 kilometers. The boat is trying to go 5 kilometers to the east. So it's actually gonna end up going down like that, right? Okay, starting from here, it's gonna start going down like that. Well, we can use this right triangle dimensions to find this thing right here, our C. And when we do, that's gonna give us our velocity, okay? In this case, we don't care about negative because once you square it, it's gonna be positive anyway, right? So we're just gonna go 2 squared plus 5 squared equals C squared. That's 4 plus 25 equals 29. So that's gonna be 29 equals C squared. When you take off the square, you have to do a square root. So this is gonna equal square root of 29, which if you put it into your calculator, is gonna give you 5.38 or 5.4 kilometers per hour, okay? With knowing all that information, we can do 3.1C. If an airplane undergoes a displacement of 5 kilometers northwest in 1.2 hours, what is its average velocity? Okay, that's this thing right here, right? Displacement over time. So it's just gonna be the displacement is 500. The time is 1.2 hours. So 500 over 1.2 is gonna give you 416.7 kilometers per hour. If a car travels 12 kilometers south, then 5 kilometers north, in 0.25 hours, what is its average velocity? Okay, velocity is displacement, watch. 12 hours south, then 5 hours north. What's the displacement? 7, right? The displacement is 7. Because it doesn't actually travel 17 miles away from its origin. It traveled 12 and then went back 5, so it's only 7 miles away from the origin of where they started. Displacement is 7 and the time is 0.25. For your average velocity, that's going to give you 7 divided by 0.25 is 28. However, they also ask you for your average speed. Well, the average speed is going to be the total distance. That's 12 plus 5, which is 17. 17 divided by 0.25 is going to give you 68. Okay, so velocity is 28 and the speed is 68. Both of them are kilometers per hour. Then it says number 3, calculate the magnitude of the resultant velocity of a canoe if the speed of the current is 8 kilometers per hour and the canoe is paddled across the creek at 6 kilometers per hour. I'm going to let you do that one on your own. Okay, I'm going to let you do that one on your own. Use 3.1b in the example to help you, and I'm going to tell you your answer that you should get right now is going to be 10. Okay, it should be 10, but make sure you know how to get that. Okay, now we're going to go into example 3.2 and example 3.3 to talk about acceleration. Acceleration is like when you get faster in your speed, okay? But acceleration can also, a negative acceleration can mean when you get slower in your speed, and sometimes they're going to call it deceleration. But sometimes they're just going to refer to it as acceleration because there is no formula for deceleration. It's just that you're going to end up with a negative and then you know what you're doing, okay? So the formula here is final velocity. Acceleration is final velocity, velocity final, minus velocity initial, what you started with, over time, okay? So the final velocity minus the initial velocity over time. Be careful of that. You don't want to just say the bigger velocity minus the little velocity, because if your initial velocity is bigger, it's because you're decelerating, because you're getting slower, okay? Look what it says in example 3.2. A stationary automobile accelerates from rest that rest is 0. Okay, so the initial velocity is 0. Okay, it accelerates from rest to 20. That is the final velocity, 20, in 10 seconds. Okay, in 10 seconds. So 20 minus, so then it says, what is the acceleration of the automobile? Well, this is our formula, final velocity minus initial velocity over time. So it's going to be 20 minus 0 is 20. 20 divided by 10 is 2. That's going to be 2. Then we look at our units. 2 looks like meters per second is what they're using. Okay, so then if you go over to, seconds squared. That is your formula for velocity. Then if you go to example 3.3, it says a car is traveling at 30 miles per second, 30 meters per second, 30 meters per second, that's your initial velocity. The driver brakes for 3 seconds without turning, that's your time. At the end of this time, the car has a speed of 18, that's your final velocity. What is the car's acceleration? This is where we're going to get a -1 so that we know that they were decelerating. So that's going to be 18 minus 30 divided by 3. Which is going to give you a -4 meters per second squared. Okay? Then if you look at example 3.4, if an aircraft starting from rest, that's 0, okay, that's your initial velocity when it says rest, accelerates at 16 meters per second squared, that's going to be your acceleration. What is its, for 15 seconds, that's your time, what is its final velocity? So you're looking for VF, okay? So we need to solve for VF, so we're going to bring 15 over here. 15 times 16 is going to give you 240. You don't do anything with that 0 because it says 0, so that is your final velocity. 240 meters per second. Okay, I want you guys to try 3.1D on your own, and then we'll check the answers in the next lesson, which will be, should be next week. I think you guys have science next week. Yeah. Okay, so let's just talk about frame of reference really quick. Let's read over this. All motion must be measured relative to something. Consider the canoe being paddled downstream in figure 3.8. Go over there and look at it. Make sure you remember what they're talking about. We measured the canoe's velocity as 5 kilometers per hour south relative to the water. But since the water itself is moving south at 2 kilometers per hour, the canoe actually moves 7 kilometers per hour relative to the shore. The shore is the side where the dirt in the tierra is by the river. We have to measure it by that because that's not moving, okay? It says a frame of reference is the space relative to which motion is measured. So if we're going to talk about that it's moving 7 kilometers per hour, it's moving 7 kilometers per hour according to somebody that's on land. We typically describe a frame of reference as belonging to some object which is treated as being stationary, okay? So it needs to not be moving. That's what stationary means. And then the rest you can read on your own. But I just want you to see that in the fact that if you're going to talk about a frame of reference, you have to talk about a frame of reference according to something that is not moving. So when you see a car accelerating or a car at a specific velocity, it's because you are not at that velocity, so you're watching that car go fast. Okay, so you're the frame of reference that's not moving. The same thing with the shore for the river. That's a frame of reference. Something that doesn't move, that you can measure something that is moving according to that. Okay? If you have any questions about any of this stuff, let me know. Just remember, you need to have 3 sentences on dynamics and mechanics, 3 sentences on acceleration, 3 sentences on frames of reference. You need to show me that you did all the practices with me or before me, then checked it, and make sure you do 3.1D by yourself. Thank you. Bye.